I have two problems here, and they require the use of the trig identities to simplify them down as much as possible. So here's his first one. It's the sine of theta times the quantity 1 plus a tangent squared of theta over the cotangent. So the first thing you want to do is just look at it, see if anything pops out, if there's anything you can simplify right away. And in the numerator here, there's one of the Pythagorean identities right there, 1 plus tangent squared of theta. And if you don't remember, 1 plus a tangent squared is equal to the secant. Secant squared. So we can just put in a secant squared in place of that 1 plus tangent squared. So this turns into the sine of theta times the quantity, the secant squared, over the cotangent. And this is a division problem. So you can look at this as the secant squared of theta divided by the cotangent, but that's just basically times 1 over the cotangent. And now you can say this is now equal to the tangent, so that's secant squared of theta times tangent of theta, and you can replace this with sine over cosine. So that's secant squared theta times the sine of theta over the cosine of theta, and also replace secant with its respective function. Maybe you might get something out of it. So that's going to be secant squared is 1 over the cosine squared times the sine of theta over the cosine of theta. And you see we didn't really get anywhere. It's just sine over cosine cubed. But maybe that, and you can also kind of see that the sine outside won't do a thing. So we might just have to do something else with it. So it's sine of theta times the quantity, the sine of theta, over the cosine cubed. We can combine the sine squared of theta over cosine cubed. And you see that the highest power on this is 3, but you can actually combine it with powers of 2, with 2 powers. With everything raised to the second power. I'm sorry I'm rambling, it's hard to do this on the fly. So, we can say this is sine of theta, well, sine squared of theta over the cosine squared of theta times 1 over the cosine of theta. This is equal to the tangent squared, and this is the secant. And it pretty much looks like that's it. That's all we can do to simplify this down. So that's our answer. Now here's the second one. It looks a little more daunting, but it's not that bad. It's 2 times the cosine times the cosecant times the quantity 1 minus the cosine squared over the tangent. And again, you ask yourself, is there anything that pops out? Well, there kind of isn't, but there is. Remember the Pythagorean identity, the basic one, the first one I proved in that video, which if you haven't seen it yet, go click the link on the annotation and go watch it. Sine squared of theta plus cosine squared of theta equals 1. You can do a bunch of things with this. You can subtract off things. And to make it look like that, we subtract off a cosine squared from both sides. And you just have sine squared is equal to 1 minus cosine squared. So you can put a sine squared in place of this. So let me erase that. Alright. Now, we just put a sine squared in that place, so 2 cosine theta cosecant theta times the sine squared of theta over the tangent squared. Excuse me, just the tangent, just 1. And now the next thing you want to do is ask, is there anything else I can do? Well, you can put this as a multiplication. That becomes sine squared times 1 over tangent, which is sine squared times cotangent. And I'm just going to speed it up a little here. Sine squared of theta times the cotangent, which is the cosine of theta over the sine. You see that we have signs that cancel here. So that cancels, that reduces to a power of 1. So all of this is the sine times the cosine. Now I just gotta find where my tile erasing thing went. So that's a sine times the cosine. That goes inside the parentheses now. But we can actually drop them. So 2 times the cosine of theta times the cosecant of theta times the sine of theta times the cosine of theta. And we're almost done. Now, more things may pop out. Remember that the cosecant is 1 over the sine of theta. And we actually have a sine right next to it. So these will just cancel out and be 1, meaning they'll pretty much disappear. So, I now have 2 times the cosine times the cosine. And this becomes 2 cosine squared of theta. In the next video we'll do 2 more, and I'll also introduce you to solving trig equations.